to make the best use, to make it more tolerant. And also, we have the protein crystal growth device with us. And, well, actually, at the space station, the Japanese crystal growth samples will be delivered shortly. And using this, we will be able to produce good protein crystals. And this could be used to develop new, more effective flu vaccines. And we believe that such experiments that take place in outer space will serve the people on Earth well. Thank you very much.
From Tanegashima, the HTV will be sending up supplies now. What do you think about this? About the HTV? Well, yes, in September, around the middle of September, we will get supplies from HTV. So Japan has Kibo up here, and daily supplies and experiment material will now be sent from Japan as well. You have a lot to contribute, and I believe for the manned experiments up in space, as a Japanese astronaut, I am really proud of this. Using Japanese technology, maybe we can go to the moon and to Mars, and maybe Japan can play a major role in the manned missions to other stars now. Yes, I would like to ride the HTV and go to the station myself. Commander Pataka, thank you very much. I think you only have 5 more days to spend with Koichi. I hope you have a very wonderful 5 days. Let's say thank you to the 2 astronauts. We have 30 seconds left. 30 seconds. Maybe have one word from you, Commander.
Okay, thank you very much, Tokyo, for your interesting questions. And one more, I would like to express my gratefulness to JAXA and Japan for being with us in this unbelievable project named ISS, and for such professional and well-prepared astronauts. Keiichi Wakata.
And thank you and goodbye from Earth.
This is Mission Control Houston. View here inside the Destiny Laboratory, where pilot Doug Hurley and flight engineer Tim Copra are working at the controls of the Space Shuttle's robotic arm. Teams here on the ground confirmed that the robotic arm is officially grappled to the logistics carrier on the end of the exposed facility. It means it's grabbed on, and the next step will be for Mission Specialist Julie Payette inside the Kibo Laboratory to work the controls that will release the exposed facility's hold on the logistics carrier so that the robotic arm can take over its weight.
We did go safe on the arm. We copy, and we're taking a look down here.
Mission Specialist Julie Payette has now made it to the soft docked mode for the logistics carrier, an intermediate mode between fully latched and unlatched.
Station Tsukuba on the big loop. We have a good indication for the AFU-10 fully open. Doug and Tim, you are go to on-berth the jelly.
We copy on the big loop. Go for on-berth.
And Skipper copies and concurs.
Logistics carrier here still continuing to move slowly away from the exposed facility of the Kibo Laboratory. It's in the grip of the station's robotic arm, driven by pilot Doug Hurley and flight engineer Tim Copra inside the Destiny Laboratory of the space station. And it will now be making its way to the Space Shuttle's robotic arm, where Commander Mark Polanski and Mission Specialist Julie Payette will be waiting standing by to take over by gripping it with the shuttle's robotic arm and then reinstalling it into the cargo bay.
Endeavour station on the big loop. The SSRMS is at the JLE handback position. Your go for grapple.
Copy that. Thanks, guys. Great job. We'll put our grapple in work.
Once this handoff is done, the shuttle's robotic arm will be installing the logistics carrier into the shuttle's cargo bay. And then from there, teams on the ground will begin taking over the robotic work for the day. They'll start moving the mobile transporter, the rail car that the station's robotic arm sits on, from worksite 8, where it currently is, to worksite 4, further into the center of the station's truss system. And then just before the crew goes to sleep on orbit, the teams on the ground are going to be powering up the station's dexterous manipulator, or Dexter as it's also known, another element of the station's robotic systems. And that's going to be the focus of one task, if time permits, on tomorrow's spacewalk, to get some of its thermal covers resituated. Space Station robotic arm here being driven by pilot Doug Hurley and flight engineer Tim Coper, backing away from the logistics carrier now that the Space Shuttle's robotic arm has a good grip on it.
Julie's done a great job, and if you concur, we're going to proceed to activate the latches in step 5 of our procedure. Endeavour Houston on the big loop. We concur. Great work, and you are go to proceed. Thanks.
Logistics carrier now in place inside the shuttle's cargo bay, as you heard from Commander Mark Polanski. He and Mission Specialist Julie Payette have been working the shuttle's robotic arm, moving it into place, and now all that remains is to actually activate the latches that will hold it still during the Endeavour's landing. And the station's robotic arm in motion again as it moves to its park position, at which point the mobile translator, the rail car that the robotic arm moves along, will be able to move from the worksite 8 that it's currently at further towards the center of the station to worksite 4. Station's arm is the largest of the robotic arms currently on orbit. It's about 57 feet long and has 7 degrees of freedom. That's the areas that it can move at, as you just saw it moving around its wrist joint there.